So question 10, the number of molecules of a certain drug in the bloodstream t hours after it's been taken is represented by the equation. Mt equals negative t cubed plus 3t squared plus 72t. Okay, that's it, but we do have a restriction here. T is between 0 and 10. So that's the equation. It's a cubic function. And yeah, we've got a rate of change question here in Maxima and Minima. So 10.1, determine the molecules of drug in the bloodstream 3 hours after the drug was taken. That's a pretty easy question. They didn't ask anything about a rate like they do in 10.2. They didn't ask anything about a maximum. So literally all we do is we sub in 3. So sub in 3 here, sub in 3 here, sub in 3 there, plug it into your calculator, and it's just going to give you an answer of 216 molecules. That's it. That's the answer. 10.2 is a bit different though. Determine the rate at which the number of molecules of the drug in the bloodstream is changing at exactly 2 hours after the drug was taken. The rate at which, so that means first derivative immediately. Straight off the bat, we do our first derivative. Okay, but just to apply it to this question, it would be m dash t or m prime t. Okay, I'm just going to clean the screen quickly so it looks a bit pretty, just like you. Let me just write the 216 here. That is our first answer. So m prime t is equal to negative 1 times 3 is negative 3t. 3 minus 2 is 1. Sorry, 3 minus 1 is 2. Silly me. We just subtract 1. That's how we get the squared. Plus 3 times 2 is 6. 2 minus 1 is just 1. So that's going to be 6t plus 72. 72 times 1 is just 72. 1 minus 1 is 0. Anything to the power of 0 is 1. So 72 times 1 just gives us 72. So that's our first derivative, right? At exactly 2 hours, so now we sub in 2. Sub in 2 into the equation and it gives us 72. So 72 molecules is the answer. The reason why we complete the first derivative here, guys, is because it said rate. That's it. That's the only reason. And after we complete the first derivative, then we sub in 2. That's the question. Okay, I'm just going to clean the screen quickly. 10.3, how many hours after the drug will the rate at which the number of molecules of the drug in the bloodstream is changing be a maximum? Lovely question here, playing on the section's name, Maxima and Minima. So with this, we utilize our first derivative once more, then the second derivative equated to 0, and we solve for t. It's asking for a maximum here. So we know that our first derivative was negative 3t squared plus 6t plus 72, right? We're using that answer from 10.2. To complete our second derivative, negative 3 times 2 is negative 6. 2 minus 1 is 1, so that's just going to be negative 6t plus 6. The derivative of a constant is 0, right? And now we equate our second derivative to 0, and we solve. Negative 6t plus 6 is equal to 0. Therefore, t is equal to 1. And that is the question. Therefore, the maximum rate of change of the number of molecules of the drug in the bloodstream is after 1 hour. How many hours? It's just 1 hour. That's it. That's the question.